Hi everybody. Today I'm going to show you how to model a 3D part and apply load, which is pressure in this case. The part actually is given in Abaqus documentation. So if you just click this one, Abaqus documentation, and by the way, Abaqus documentation is available online as well. So this is documentation, and here is for tutorials. Getting started with Abaqus Interactive Edition, just click this one, and using chapter number 4, using continuum element, and here's example is modeling this connecting lug. So the dimensions as given here in meters, and the problem is to apply 50 megapascal pressure on the bottom half of this hole. So quickly you can go through steps of this modeling process, and here is many figures that show step by step how to model. I'm going to model maybe in different method, but the most important is at the end you should have the similar model as this one. Let me start first. So I'm creating new part, or save this one, partition. Here is I'm going to create 3D connecting lug. So in this one connecting lug. Okay, so this is the name of the file. Create part. The part will be three-dimensional, deformable, and it is now solid, not shell. And the maximum dimension here, the largest dimension, it's 0.125 meter. So if we set the approximate size to 0.5, it will be accepted. So here I'm going to draw rectangle, right click, and this dimension, which is the height, which is 0.05, so this one 0.05 meter, and this one is 0.125 meter, which is given here. The radius of this circular end, the radius of the outer one was 0.025 meter, and for the smallest one it is 0.015 meters. So I'm going in my modeling. You can do another way. Just offset this curve. Done. I want to offset by the value of 0.025, and clicking flip because it is offset in this side. I want to flip, so it is here. Calculating circle, sorry, this one again. Done. Okay, so here's circle from the center point to this point, and then delete all of unwanted, which is this part. The radius of the inner one is 0.015, so it's a circle from the same center, and the radius is 0.015 meter. And now just we finished sketching the side view of the part, so done. And it should be extruded in the other direction, which is Z direction, by 0.2 meter. So 0.2. Okay, so this is the part. The next step is to define material, create material, and call it, for example, steel. And the mechanical properties is elasticity, and here it is given for us. Modulus of elasticity is 200 gigapascal, and the Poisson ratio is 0.3. So this one is 210 to 2 power 9 gigapascal, and that is 0.3. Okay, and define section, we can call this as well steel. Okay, and assign this part for the section we just created, which is steel as well. The next step is to define assembly. So create as instance part, independent or dependent, by the way. Okay, and here is step, create a step, static general, continue, accept the default. Nothing will be changed unless you check this text here and they ask for different output, whether it's field output or history output. So interaction, here we don't have interaction as it is one part. And here the load, I'm going to apply boundary condition first. So here's a boundary condition. So starting with boundary condition here, symmetry, anti-symmetry or encaster, select this area and done. And we are using encaster, which means it's constrained in all directions, x, y, z, and rotation about x, y, and z. Okay, so here is we just created the boundary conditions. I'm going to show you apply the load. The load should be applied to the bottom half of the whole surface. So first I'm going to show you how to partition. So partition face, which is this face, and we choose even sketch or datum, shortest path between 2 points. So let me select this one, done. And datum plane, this one. So cancel. If we check, okay, I'm going now to partition, cancel this one. So we are in load, tool, partition, cell, define cutting plane, point and normal. We can choose this point and this normal, create partition, done. So now we have the whole component divided in two parts, the upper part and lower part. So the stress here, it's load and step, it's pressure, continue, affecting on this surface. Okay, and the magnitude of the pressure is 5 10 to power 7, 5 10 to power 7, which is 50 megapascal. Okay, like this. So now we finished the load, the mesh. Okay, according to the rules or the instructions given in the file, so I'm going to partition this part even more. So before partitioning I have to create datum point which is offset from a point, and selecting this one, and the offset will be in X direction by the value of 0.75, and clicking. So here is the point, this is the point, the datum point that we created. Then partition the cell, defining cutting plan, and here is it asks us to select the cells, so I'm selecting both of them. Done. Point and normal, and selecting this point and that normal here, create partition. So now we can say done. The part is partitioned in order to get reasonably good mesh. So now it is partitioned in this way. The following step is to, from here, see the part and specify global size of 0.007 millimeter. So I'm going to here, and the global to be this number. Apply, then pressing OK, and then from the main menu bar select mesh element type and element type, and choose the element type. Because of this partition you have created, the part is now composed for several regions. Use the cursor to draw. So here I'm going to define mesh element type and selecting the whole part. Done. It's standard. Instead of being linear, the default, I'll choose quadratic, which has 20 nodes and still reduced integration. So click OK, and then mesh the part. Yes, here's the geometry that we have. Yes, the mesh in this area is sweep mesh, which was colored yellow. So we may change this type as following. Select this icon here, done, and sweep. Instead of being advanced front, let be medial axis, and select OK. Delete mesh, and then select again to mesh. So here's the geometry is similar to that given in this part here. So now we just completed the modeling process. Now the time for job analysis. So I'm going to create job number 1, continue, OK, dismiss, and go to file, set work directory, and select 3D connecting lung. OK, and submitting here job, and waiting for the results to be submitted. Now the job is completed. Here is the results. So taking this one to see the stresses, vertices, sigma x, sigma y, sigma z, and so on. One thing we can add is to activate and deactivate view cut, like this one, so we can have X plan, and we can move from by this slider here to see the internal stresses, and here's the other side as well, and this one for Z plan. This is the addition given here in the file, which you can check. The maximum volume stress 4.26, and here's the modeling process. Thanks for watching.